Okay, new problem. So I'm trying to find find the antiderivatives here, and I have an annoying square root in my problem. Trig substitution will be an option. So I gotta say, well, which trig identity does 9 minus x squared look most like? Well, you got a number minus something squared. Looks awful lot like this one. A number minus something squared. Looks like we're going to have to do a sign substitution. Now, but if you look at this, wait a minute, we don't have 1 minus something squared, we have 9 minus something squared. So here's what I'm going to do. I'm going to make this look more like 1 minus something squared. So I'm going to say I don't like this. I don't have 1 minus something squared. So I'm going to say, all right, I'm going to factor out a 9. So I'm going to pull out a 9. If I do that, I'm going to put a 1 here. And then I got to do x squared over 9 here. So great. If I distribute, I see that this is correct. 9 times 1 is 9. 9 times x squared over 9. Well, 9s will cross off. Give me that. All right. Square root of 9 is 3. Put that guy on the outside. Now on the inside, I want to make this look like 1 minus something squared. So what I'm going to do is I'm going to write x squared minus 9. I'm going to rewrite it as x over 3 squared. Aha! Now, this does look like a number minus something squared, which is what I got here. So what I'm going to do is I'm going to let x over 3 be sine of theta, because I want to replace this whole thing with sine of theta so that it becomes sine squared. So I'm going to let x equal, I'm going to let x over 3 equal the sine of theta. So in other words, x equals 3 sine of theta. So dx d theta is equal to 3 cosine theta. So dx is equal to 3 cosine theta d theta. All right. So now I just do algebra. I say, all right, well, replacing x, I'm replacing that with 3 sine theta. So that will become 9 sine squared theta. All right, I got that 3 there. That's just hanging out. All right, I'm replacing x over 3 with, I'm taking this x over 3 here, and I'm replacing that with sine theta. So I have 1 minus sine squared under the square root. And now dx, I am replacing dx with 3 cosine theta d theta. All right. So let's see. 9 divided by 3 is 3. All right. Well, actually, 3 crosses off with this 3. I'll leave that 9 alone. So I got 9 sine squared theta on top. On the bottom, 1 minus sine squared. Replace that with cosine squared. All right. And I still have that cosine of theta hanging out there. All right, now the square root of cosine squared. That is absolute value of cosine. But now, in the other, in video, I guess number 1 or 2 of this section, I believe, we reasoned, hey, we don't need the absolute values here. We can just drop them because the cosine of theta will always be positive anyway. So here we're using angles between negative pi over 2 and pi over 2. Cosine theta is positive. So we don't need the absolute value bars. We can drop them. They're not doing anything. So I'll be able to cross off these cosine thetas here. Great. So now, pull out the 9, and I'm trying to find the antiderivatives of sine squared theta. That's kind of a problem. So sine squared, that's not going to be fun. So you might want to start thinking of trig identities that'll help you. Well, I know this one. I know that cosine of 2 theta, double angle formula, cosine of 2 theta, I know that that is cosine squared theta minus sine squared theta. All right. And then I know, well, because sine squared plus cosine squared is 1, I know that I can take cosine squared, and I know that I can replace that with 1 minus sine squared. If I do that, I get a new identity, 1 minus 2 sine squared theta. So I know this trig identity. For whatever reason, I always need to drive these other forms of the double angle formula for cosine. So I know this one, and then I always got to do this process and say, okay, cosine squared is 1 minus sine squared. So cosine 2 theta, I know I can replace it with 1 minus 2 sine squared. Now, why was this helpful? Well, look here, sine squared of theta. That does not have a nice antiderivative. I don't know what that is. Cosine of 2 theta. Aha, that has a really easy antiderivative. I can just guess that one. Antiderivative of this guy won't be bad at all. Antiderivative of this guy is very difficult. Antiderivative of this guy is easy. So what I'm going to do is I'm just going to solve in this equation. I'm going to solve it for sine squared. I'm going to subtract 1 from both sides and divide by -2. So cosine of 2 theta minus 1 divided by -2 is sine squared. Yay! This guy's got an easy antiderivative. This guy's got a hard antiderivative. I'm going to take this guy and I'm going to replace it with this thing. So cosine of 2 theta minus 1 all over -2 d theta. All right, let's see things I can do here. All right, I'll pull out a 1/2 here. So I'll get rid of that 2 on the bottom. So that 2, pull out that 1/2, ends up right there. All right, now I got a -1 left over in the bottom. Cosine of 2 theta minus 1 divided by -1. Well, let's get rid of that. That'll turn this into +1 minus cosine of 2 theta d theta. All right. Now, an antiderivative of 1, d theta. Antiderivative of cosine of 2 theta. I can do 1/2 sine of 2 theta. You can check if you're right. Derivative of sine is cosine. So we have cosine of 2 theta. But remember the chain rule, so we got to do times 2, derivative of the inside, 2 times 1/2, they cross off. Yay, it gives me that. So I guess it was good. All right. But again, I have a problem that started with x's in it. I need my problem to end with x's in it. So in my problem, I let x over 3 be the sine of theta. All right, I'll draw a picture here. So there's theta in a triangle. So sine, it's opposite over hypotenuse. So in my triangle, my hypotenuse is 3. My opposite side will be x. Use the Pythagorean theorem. That will make this side √9 minus x squared. What was the point in doing that? Well, I'm trying to figure out sine of 2 theta. So this diagram will be helpful. Well, why will it be helpful? This is a sine of 2 theta. So I somehow have to fix that. Well, I can. More trig identities. So I want to get rid of sine of 2 theta. Well, sine of 2 theta, here's another trig identity that's good to know, is 2 sine theta cosine theta. Double angle formula for sine. All right. So sine of 2 theta is 2 sine theta cosine theta. Well, great. Now I'm going to be able to get rid of sine of 2 theta here. I can say, okay, sine of 2 theta. It's 2 sine theta cosine theta. Well, let's look at the picture. Sine of theta. It is opposite over hypotenuse. Cosine theta. It is adjacent over hypotenuse. Great. So now I'll be able to replace this sine of 2 theta. Now what about that theta? We got to get rid of that too. Well, look what we got here. Sine of theta is x over 3. Well, what that's going to mean then is theta is the sine inverse of x over 3. I know that because I took theta to be angles between negative pi over 2 and pi over 2. Sine inverse spits out angles between negative pi over 2 and pi over 2. So this works. Can indeed just say theta is the sine inverse of x over 3. Well, now I go back here and I say, okay, theta, I know that's sine inverse of x over 3. Sine of 2 theta here. We said that we could replace that with 2 times x over 3 times root 9 minus x squared over 3. And then we got our plus c here. And we're done.